Okay, hyperbolas. We got a little behind in class today, and different classes were in different places. So I'm just going to do the notes over. You can fast forward to where you left off in your class. So, the hyperbola. First thing we wanted to note was note A is not necessarily with hyperbolas. With ellipses, A is always greater. But with hyperbolas, A is not necessarily greater. However, I'm going to go to a different color. A is always under the positively squared term. Positively squared term. Okay, so let's look at horizontal and vertical ellipses. With a horizontal ellipse, we note that a squared is under the x. X squared is positive, a squared, that's where a squared is. In the vertical ellipse, we notice that a squared is under the y. Y squared is positive, x squared, it's minus x squared, so x squared is negative. A is under the positively squared term. We note that the center is h and k as usual. To find the vertice of a hyperbola, move left and right. It's horizontal, so left and right, a units from the center. To find the foci, move left and right, c units from the center. Notice that your foci will be inside your arcs, on the inside of your arcs, I'm calling that. Here is your center. Okay, so there's your center. A is the distance between the center and the vertice. One vertice, two vertice. Okay? Okay. Now with a vertical hyperbola, here's our center. Here is A. It's down and up A units to get to the vertice. Vertice 1 and vertice 2. Let's do a problem. Straighten all, just simply get all this stuff clear. So we have a hyperbola. As always, the first thing we want to decide is what is the orientation of the parabola. It's y squared is positive, x squared is negative, so we have a vertical parabola, a hyperbola, vertical hyperbola. A is under the y squared, a is 4, b is 3, a squared, b squared. The center is 1, 2. Now let's graph it. So if we go down, we have 1, 2, there's our center. With the hyperbolas, the first thing we do is sketch the box that creates the hyperbola. So it's vertical, so we go up and down A, 1, 2, 3, 4, top of the box. Down, 1, 2, 3, 4, bottom of the box. We're going to go to the right, how much? B, 1, 2, 3, and 1, 2, 3. So we have the edges of our box. Let's box it in. So we're going to make a dotted box. This box doesn't really exist, but we use it to graph parabolas. Okay. Now what we want to do is establish the vertice. The vertice, it's a vertical parabola. So the vertices are at the top and center of the box and the bottom and center of the box. So let's get these coordinates. So they are 1, 6, and 1, -2. The next thing we want to do is we want to create our asymptotes. Asymptotes go from the opposite corners. So let's graph. These are also, quote, not real. They are not part of the actual hyperbola, but they create the hyperbola. So let's draw in the asymptotes. One corner to another. These are just lines. Y equals mx plus b. Okay. So, in fact, y equals a over b times x plus c. Okay, so y equals a over x. Now, we have vertices, we have asymptotes, we can draw the hyperbola. Let's draw it. The hyperbola goes from the vertice to the asymptote but never crossing it, to the asymptote but never crossing it, and down. Okay, so there we have a hyperbola. Now the foci, that's C, right? So we can highlight up the top that up in our notes that C squared is A squared plus B squared with hyperbolas. So it's A squared minus B squared with ellipses. So let's calculate that. C squared equals A squared plus B squared, which is 16, 4 squared plus 3 squared is 9. C squared. C squared is 25, so C is the square root of 25, which is 5. Okay, so C is 5. Let's sketch that in our graph. So from the center, we go along up 5. 1, 2, 3, 4, 5. There's your first foci. Go down 5. 1, 2, 3, 4, 5. There's your second foci. Now the foci will always be, I'll call it inside your loops, your hyperbola arcs. Let's do it again. So now, what term is positively squared? X squared is positive, so this is a horizontal ellipse. Excuse me, I'm saying ellipse, and I mean hyperbola. A horizontal hyperbola. A is 4, and B is 2. Our center is 2, negative 3. Let's graph it. So go down 2, negative 3. That's our center. I'm going to create the box now. So we're going to use A and go left and right. A is 4. 1, 2, 3, 4. 1, 2, 3, 4. That's part of the box. And let's go up 2 because that's B. 1, 2, top of the box. Down to bottom of the box. Let's just draw in our box. Okay, now we're going to draw the asymptotes from one corner to another of the box. So dotted lines for your asymptotes. Okay, let's do vertice. We're going to draw the vertice. Now this is a horizontal ellipse, so your vertice are at the very left and center of the box and right and center. Left and center of the box, right and center of the box. So I'm ready to draw from the vertex to the asymptotes. I sketch my my hyperbola. Okay, hyperbola. Now, let's draw our coordinates. So our vertices are at 6, negative 3. 6, negative 3. And all the way over here at negative 2, negative, negative 2, negative 3. I was getting confused. Negative 2, negative 3. All right, so the foci, they're going to be in here somewhere. We've got to solve for C squared. So C squared equals 16, 4 squared, plus 4. C squared equals 20. C equals the square root of 20. Well, the square root of 20 is approximately 4.5. So I'm going to sketch it first. Looking at my graph, I'm going to go from the center 4.5. 4.5. So they're right in there and right in here. 4.5. Okay? Now let's do the coordinates for foci, which we are adding radical 20 to the center on the x coordinate. So we look at our center and we say the foci is at 2 plus radical 20, and then we just keep y the same, and 2 minus radical 20, we keep y the same. There's our foci. And you don't have to calculate that. You can just make sure that you add the radical 20 to the x value because it's going along the x-axis. All right, let's move over to the second side. We're on the second side. let's do problem number 2. Let's start with problem number 2. Some of you have done this in class. We're going to do problem number 2, and then you can stop the tape and do problem number 1. So problem number 2, we want to put the positively squared term first. Y squared minus 2y, leave a space, minus 4x squared minus 16x, leave a space, equals, move the constants to the other side, 19. Add them to both sides. So now I'm going to complete the square. And I say, what is negative 2 divided by 2 squared? It's y minus 1, negative 2 divided by 2 squared. What is negative 1 squared? Plus 1. Now, if I add it to the left, I'm going to add it to the right. Now here, what we first need to do is factor out, there is an a term here in front of the x squared, so we need to factor out negative 4, which means divide both of these terms by negative 4, leaving me with x squared. 16 divided by negative 4 is positive 4x. Leave a space, because we've got to complete the square. So I'm going to complete the square, and I'm going to say 4 divided by 2 is going to be 2. X plus 2 squared. 2 squared is plus 4. So I've completed the square. What do I add to the right-hand side? Negative 4 times positive 4. So I'm going to add negative 4 times positive 4. Then I'm going to add all those together, all these three things together, negative 16, positive 19, and positive 1. So we have 20 minus 16 is a total of 4. So let's write this out. We have y minus 1 squared minus 4 times x plus 2 squared equals 4. Well, I know that I want hyperbolas also have a 1, are always equal to 1. So let's divide everything by 4 to get to our standard form. We get 1 equals, this is y minus 1 squared over 4 minus 4, nope, not minus 4. This is, the 4's cancel, so that's minus x plus 2 squared over 1, because the 4's just simplify to 1. So all you had to do was transform it to standard form. Let's verify that we know that the center is negative 2, positive 1. So we have a center of negative 2, positive 1. We know that A equals 2 and B equals 1. There's our hyperbola. We could start getting the center, drawing the box. All right, let's keep moving. Write the equation of a hyperbola from the given information. So, all right, so we've got two problems here. Let's do number 2 first, since I started there. Okay, I'm going to sketch. I always want to sketch. Negative 5, 1, negative 7. Okay. So I'm going to say the vertice. 1, 2, 3, 4, negative 5, positive 1. Then I'm going to, that's a vertice. And then negative 5, negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 7. So there's another vertice. So the vertice, remember, is the top and bottom of our box. So what's our center? We have 8 places in between, so 1, 2, 3, 4. We are at the actual center is going to be negative 5, negative 3. Okay, negative 5, negative 3. Now let's see what else we have. We also have the foci. So it's this number added to the center along the y-axis. So this is going to be a vertical ellipse. So let's write that. Ellipse, I keep saying that. Vertical hyperbola. Vertical hyperbola. So radical 97 is, let's see what that is in terms of seconds. 97. Well, 9.8. So that is 9.8. So from the center, we go, this is up 4, and then we go up 5 more. 1, 2, 3, 4, 5. So this was at 1, and this was at 6. So we're going to go up 5 more and 0.8. So it's almost to here. There we go. And then we're going to go from the center down 9.8. So we've gone down 4. 1, 2, 3, 4, 5. So that's going to be at negative 12. And so our foci is going to be at negative 12.8. Okay, so we've got dots and trying to get boxes. So the C value is radical 97. So let's figure out C squared equals A squared plus B squared. I know C, radical 97 squared equals, I know A because the distance from the center to the vertex is 4. So let's write that somewhere. A equals 4. Okay, C is radical 97 and A is 4. 4 squared, 16 plus B squared. Okay, so let's start working this out. Radical 97 squared is 97 equals 16 plus B squared. B squared equals 81. B equals 9. So that tells me the length of my box. So let's go to the center and count 9. We have 5, 6, 7, 8, 9. So that's at 4. So 4, negative 3 will be the side of the box. And 1, 2, 3, 4, 5, 6, 7, 8, 9. If this was negative 5 plus 9, this is negative 14. So at negative 14, negative 3 will have the other side of the box. Now let's draw in the box. Okay, and we have our box. Now we're going to draw our asymptotes from one corner of the box to another. This is going to be a very fat ellipse. So, and you'll notice, there's my, I say ellipse, hyperbola. A fat hyperbola. There we go, from the vertice to the asymptotes. You'll notice when the foci is far away from the vertex, you get a kind of fatter hyperbola. Okay? Write the equation of hyperbola. We still haven't gotten there yet. So, we're going to have the positive term is going to be the y term. So it's going to be y minus 1 squared over, so that's going to be the top, minus x plus 5 squared equals 1. Okay, let's determine our denominators. What is a squared? Well, that's 16. What is b squared? 81. Notice we have a b that's greater than a, but this is still a because it's under the positive term. Okay, I'm going to leave number 1 for you to do. You have a center here at 0, 1. We have the ends of our boxes. Now, notice that the tops of our boxes, you want to get your box dotted in when you're doing these equations. Okay? So we go from straight from the vertex to the asymptote, and that will give us the top of our box. Okay, so when we're looking at this, what is A? Well, A is from the center. 1, 2, 3, 4, 5. A equals 5. What is B? 1, 2, 3, 4. B equals 4. I'm just writing an equation, so all I need is the center and a and b. So let's just do this one. We have x squared, because h is 0, over a squared, 25, minus y minus 1 squared over 16 equals 1. It's a hyperbola because there's a negative. All right, two possible equations. I know this is long. Two possible equations of the hyperbolas with these asymptotes. So the first thing you want to do is graph the asymptotes. So we have an intercept at 2. We have 1, 2, 3, up 3 over 5. 1, 2, 3, 4, 5. There's one end. And then we could go down 1, 2, 3, down 3, 1, 2, 3, 4, 5. Those are the corners of our boxes. That's a line with an asymptote with a slope of 3/5 at an intercept of 2. So here's the intercept. It's also negative 3/5. So it's up 3 to the left 5. 1, 2, 3, 4, 5. That's the corner of our box. And down 3, 1, 2, 3, 4, 5. Corner of the box. So now we can draw the second asymptote. We just plotted a line. Okay, those are the asymptotes. You can plot a line. Y equals mx plus b. Y equals mx plus b. Plot the b, then plot the slope. So we've got our box. We want two possible equations of the hyperbola. So we don't know if the vertex are here and here, so it's vertical, or here and here, so it's horizontal. So those are our two possibilities. So let's draw the horizontal equation first. Okay, this from here to here is 1, 2, 3, 4, 5. From here to here is 1, 2, 3. So if we have a horizontal ellipse, hyperbola, where the vertices are here, then what will our equation be? Well, the x squared would be positive. So it would be with, we'll have a center at 0, 2. So let's write that down. Center at 0, 2. HK. So if we're horizontal, then we're going to have x squared over 25 minus y minus 2 squared over 9 equals 1. That's if we're horizontal. Now, if we're a vertical, different color totally. If I am a vertical hyperbola, then those would be my vertex, and here's what I would be. So let's write the vertical equation. Oops, sorry. Vertical equation. If I'm vertical, then the positive squared term is y. Y minus 2 squared, it's still over 9. A would be 9 minus x squared over b would now still be 5. I mean, b would be 5. But the actual picture doesn't change. Equals 1. So those are our two possibilities. All right, I know that was a lot. I'll see you tomorrow.